Hi everybody, Neil here from AS-CAD Services. I got an email off one of my customers earlier today and he was asking, is there an easy way to put railings on a plate welded between the two flanges of an I-beam? And there is a way of doing it, and the workflow is quite simple. I'm just going to demonstrate that to you. There's nothing in Advanced Steel railing macro that'll do that for you in one hit, but as I said, the process, the workflow is not difficult. I'm going to enhance this a bit more. I did a video of this for Greytech when I worked for them, and I basically did the same thing. I put some railings on plates welded to the flanges, etc. But my customer specifically wants to use solid stanchions. So 38 diameter solid stanchions, ball posts, whatever you want to call them. And I'm going to show you how I do it. I used to spend a lot of my life putting railings on platforms, one thing or another. And a lot of water authorities use things like this, solid stanchions. This is one I created quite quickly, and I use the tools in Advanced Steel. These are 3D modeling tools, standard AutoCAD tools. Nothing clever about that. So I've saved this. I've just called it demo DWG, but obviously you could call it whatever you like. I'll come back to this. I'll explain a bit more about this in a little while when we use it. Okay, so here we are, and the first thing I'm going to do with this, I'm going to put a flat on the face of the flanges. So let's go to Objects, Flats, and I'm going to put it from this endpoint here to this endpoint here. You notice I'm using the shift and right click key to bring up the snaps. When I'm modeling in Advanced Steel, I generally have node on as the only snap, the active snap. If I need anything else, shift and right click. I'm going to change the plate size. I know this is a 254 beam, so I'm going to change it to a 250 plate. You notice I haven't got much here in my short list. A lot of you will see this great big long list. There are settings in management tools. I'm not going to go into too much detail about that now. The settings in management tools called preferred sizes, where you can reduce the length of this list. What I'll do at some stage, I'll do another video and we'll talk our way through that. Okay, so here's my plate. I've not welded it on, and you notice it's not aligned with the top. The plate's a bit smaller than the beam. Alright, so for people who are a bit pedantic like me, what we can do, we can move that up to center it. Of course, there's no need to do this. So what have we got? We've got 1.4, so that is moving up 0.7. There you go. I'm a happy man now. Centered plate. I think it must be a man thing. I don't know. Alright, I'm going to copy this. Dumb beam, dumb copy, as I tell people that I train. Dumb beam, dumb copy. And I'm going to copy it to this endpoint here. And then I'm going to use a dumb rotate from the endpoint there. And I'm going to rotate in this direction. And I'm going to split this beam. So I'm going to split it there. I think I had a gap set earlier. Yes, I did. And I'm going to split it at the node there. Get rid of this bit. So here we are. I've got a plate now on the front of the two beams. Next, we're going to put some railings on. So we're going to make sure we're in World UCS, and we're going to go to Extended Modeling Ribbon. And here are the railings. And as you know, if I select both these parts, the railing will automatically go around the corner onto the two beams, or onto the two plates in this case, or two flats. So my start point for the railing will be here, and my end point will be here. And it says, do you want to select a nosing point relative to the start point? This refers to nosing points on staircases. So in this case, the answer is no. The default is no. We can see that, so we just hit return. There's my railing. Simple as that. And we're going to edit it. So let's have a look, see what we're going to do. The first thing I do, kick plates. Bit of a non-starter, to be honest, in the railing macro. If you wanted a continuous welded kick plate, then that's fine, you can do that. But normally we're going to put the kick plate on with things like U-bolts around the stanchions, or you might have tab plates welded to the posts. We can't do that in the macro, so I generally turn them off, and I would model those myself. Okay, so let's have a look at the post first. Now I'm going to use a round post, and it's going to be 38 solid, and I'm going to replace this later on, but this is for placement. So I'm going to go for a 38 solid. Alignment of the post to the top. Well, I don't want it aligned to the top, I want it aligned to the face here, which happens to be right face. Two chances, left or right. I'm bound to get it wrong the first time, managed to do it every time. Set out of posts. I've got a start and end point here, start to the first post and distance to the last post. That refers to this distance here to here, post to end. And I'm going to use a standard that I know, which is Wessex Water, and it's 300 start, 300 end. And it says calculate distance for each beam. That means it's going to finish the calculation for the length on each of these beams. If I turn this off, what it'll do, it'll start at the 300 here, and whatever the centres of the posts are, I'm going to set this to 1500 centres. It'll do 1500, 1500, or close to it, allowing for equal distance. So we'll just say 1500, 1500, 1500 around the corner, 1500, and then my 300 end. They're not actually 1500, you'll notice they're 1385. That's because it's equal distance, allowing for 300, 300, and equal distance between. If I make it calculate distance for each beam, it's now 300 and 300 and equal distance between. 300, 300, equal distance between. So you can see here, this is changed slightly. So there's my basic layout. Let's have a look at the hand railings. I've got a tube hand railing here. I'm going to use a CHS. And you'll notice my short list, 42.4 at the top. I use it quite regularly. Distance to the top, that's from the top of the beam, that's the top of the plate, so we have got that slight discrepancy, and I could add it on here. I'm not that pedantic. So the middle handrail, again CHS and 42.4 by 4, and you'll notice it's being measured from the bottom up 600. I'm going to say measure down from the top 500, and there it is. And this is on slope, we haven't got slopes, so we don't need to set that. There's no ballast, this kick plate. Handrail to handrail joint, I might change this to radius. And I know that those very nice people at Lionwell Kennedy can do a 90mm radius on 42.4, so I'm going to use that in this example. Of course, you would set this to your tooling radius, so it's worth having a check, see what you can do with that. Okay. End of handrail, I'm not going to bother with that, but we know we can put a loop on the end of this, either end or various methods of. So let's have a look at the post top handrail. I don't need to worry about the fit on the top because I'm going to replace this post eventually, so I'm not too concerned about that. The post middle I am, however, because I'm using solid stanchions, I want this middle rail to be continuous, so we're going to call that continuous there. Can't turn off the weld, but obviously I'm going to delete that later. Post fixing. In this case, I'm going to use plate with bolts. And that's a mess. The easiest thing to do with this is to go into a straight view, so a front view in this case, and I can see what's happening with this plate. So let's go to post fixing. So the first thing I'm going to do, distance from the top. This is from here to here. We'll leave it at 150 just for now. Thickness of plate I'm going to make 15, and length of plate I am going to make 150, and the thickness of the plate I'm going to make 65. Again, that's a lie and weld parameters, just happen to know that. I'm going to go to parameters, fixing parameters 2, and this involves placement of bolts, placement of plate, all this sort of stuff. So what I'm going to do, the edge distance number 1 is from the top of the beam, in this case the flat, to the top of the plate. I'm going to just make that 75, just a bit of a guess there. And the offset here is the center of the post to the edge of the plate, and you can see it's 25 in this case. Well, we have a 150 plate, so to center it would be 75. I only want one line of bolts, and I'm going to center these bolts. So the intermediate distance 100, line weld again. I'm not plugging line weld, I don't work for line weld, it's just I know their standard. So the edge distance there, 150, 100 leaves 50, divided by 2 is 25, so we know that. And the distance here, so 65 plates, that'll be 32.5. There we go. And the last thing I'm going to do is the fixing bolts are going to be 16s, again specification, blah, blah, blah. And I'm going to change this distance from the top, and I'm going to guess this really. Well, it wasn't a bad guess. They are 140. Obviously, if I wanted to put an end cap on here, I would be 137, for instance, and the cap plate would be 3. But I don't need it in this case because I'm going to delete all this. And so all I want this for is just position of posts. And there it is. That's it. If that's all I wanted to do, I just need to split this plate, this beam, this flat, beg your pardon, and delete the bits I don't want. However, because this flat forms part of the railings, if I were to split this and delete it, boof, off go the railings, and we're back to square one. So unfortunately, what we need to do now, we need to delete the joint box. And if I train you or anybody else trains you, they'll say, oh, you never delete the joint box. Well, unfortunately, in some instances, we have to delete the joint box. And this is one of them. What I'm going to do now, I'm going to split this plate. So I'm going to use split beam. I'm going to split this, and I'm going to use the corners of the plate. So there you can see, look, I've split that. I'm going to split this one. Doesn't matter which corners we use. If I use that back corner there and the front one here, wouldn't make any difference. It's still going to split on those axes. Okay, so I'm going to split this again from there to there, and I'm going to delete the bits I don't want, which is those and those and those and those. Gone. Let's just rotate around here a bit. Let's do the same thing here. So I'm going to split this one there to there, there to there, and there to there. Delete, delete, delete. Now I'm going to cheat here. This is a bad habit, but just for speed, what I'm going to do, I'm going to select all of those, and I'm going to put one weld, and again I'm going to select all of these, and I'm going to put one weld. There it is. Alright, simple enough. I'm going to come back to these welds here in a minute because they're not desirable. We're going to do something with those. What I'm going to do for now, these welds, I said we couldn't turn these off. So all I'm going to do, I'm just going to select all of these welds. And I'm going to delete those. I beg your pardon, delete the corner pieces as well. Didn't mean to do that. Just quickly do that again. I need those. So remember to deselect something. I hold the shift key down, I select it a second time, and that would deselect the selection, as it were. So there we go, I've just got rid of those welds. Save me a job in a minute, that's all. And what I'm going to do, I don't need to do this, but I'm going to put the UCS at the top of this column. If I go into 2D wireframe, you can see where it is, look, center of the handrail, top of the column. And what I'm going to do, I'm going to use the good old advanced steel special part. And the central point, of course, if I hadn't moved the UCS, I could have selected it. And then it asked me to choose the special part to insert. and I'm going to go here, and it's the one that I did, which is the demo. It says block already exists because I had a little play earlier on. Yours won't say block already exists, overwrite, and because it was already in my system. So here it is, and it's inserted the block, and you can see where it's inserted it, and I'll tell you why it did that in a minute. I can add some information to this. So if we knew the weight of it, I don't know what it is, let's say it's 20 kilos, probably a bit much, 15 kilos. Coating, we're buying it in anyway, but we know it's going to be galvanized material. Other, I'm not interested in that, we're buying it in. Now when it comes to naming, I can call this, because we know we've got one, and it's called railing post, so we can use that. The free remark isn't going to be used anywhere in the system, but the commodity number is, so we can call this a 38mm diameter solid stanchion. And we'll turn off the caps lock this time and try that again. How many times do we all do that? It drives you mad. 38mm diameter solid stanchion. There you go. This is going to show on my material list. It's going to list these as special parts. It's going to use the commodity number to list it, so we know what we're ordering, how many we're ordering, etc. That is it. Okay, when I inserted this, you'll notice it inserted where I put the UCS at the top center of the railing, intersection between that and the column. That's because when I created this part, I made sure that when I saved it, that insertion point was on the UCS. So I made sure I was in World UCS, and I moved the solid stanchion from the center of the ball to the UCS 00, or 000 if you like. And the other thing I did, I put it on the layer 0. The reason you do that is when I bring it into advanced steel, I can then change the color. If I put it on any other layer, then the layer would fix the color. I couldn't change it. And then the last thing I did, because I was in an advanced steel template, is I used the purge command. I purged everything that I didn't need. So basically the layers have reduced to the just the essential layers, and any blocks, there were no blocks in any case, but any blocks were deleted, and I just ended up with the part. All you do is save that. So save as, and I just saved it in my materials library, my symbols library. I created one for myself, and that's it. And I can just call on it from that location. So that's the important thing. UCS where you want the insertion point to be, and save it onto layer 0. And here we are. This is what happens. So what I can do now, look, I can get rid of the old stanchion, and I don't need the welds here, and I don't need the plate. So let me get rid of those. I do need the bolts though, because the bolts are correctly positioned for the stanchion, because I made sure of that when I drew the solid. And advanced steel, although this is a special part, advanced steel recognizes the thickness of the plate. It won't put holes in for you. You'll notice that the holes were in the solid. Okay, so what I'm going to do now to make sure that the bolts go through all parts is use this tool, add objects to connection, and you know this works for bolts and welded connections. And I'm going to select this and these two parts, and there it is. All right, so that's it. So these parts I don't need, these parts I don't need, so let me just dump these a minute. All I'm keeping the posts for is simply to hold the place, top of the stanchion. Okay, and let's get rid of these a sec, just quickly. Need that weld of course there, need that weld, don't need that. Okay, right, so there it is. And all I'm going to do now is I'm just going to use copy. I could use the dumb copy, but I'm going to use the advanced copy, and I'm going to copy it from center there to node to node to node to node. Alright, I can delete the old advanced posts. There it is. Okay, and of course I need to copy this again. I'm going to copy this one from the center point there to node. Now this one, orientation, look, wrong. Oh sorry, I didn't copy the bolts, just copy that again quickly. So I want to copy this and the bolts. And I'm going to copy from center to node. There it is. What I need to do, I need to rotate this. So I'm going to use the standard rotate, and I'm going to rotate it from this node. And look, if I have a look at it, you can see as I rotate it, let's get it going the right way. There we go. The bolt's not going through here, so what I need to do again is use the tool to do that. Get rid of the posts, copy, boom, center to there, done. Get rid of that, get rid of that. Oh, didn't take the bolts again. I think I get the hang of this by now. Alright, so let's do that, and I'm just going to copy that from, doesn't matter really, endpoint there to endpoint. To well, that was a nice and tidy thing. So let's copy that one. Endpoint, endpoint. Oh, sorry, I should have selected the solid when I inserted it. Alright, so there we are, nice and scrappy, but happens to all of us. Alright, so what have we got now? We've got these rails. This was a continuous rail, as you know, you can see it's going through. I've got this issue where these parts are separated. So all I'm going to do, now I've deleted all the welds, I'm going to use merge beams. I'm going to merge this one and this one, and I'm going to merge this one and this one, this one and this one, and then that one and that one. So this is continuous now, continuous, continuous. But what we want to do is split this, because we're going to put a joiner in, and if we were to use a key clamp joiner, there's 20mm gap between the beams. So I'm going to go into a 2D wireframe in it, and you can see this happening. And I'm going to split beams again. So I'm going to split this one, and this time I'm going to set a gap 20, hence the gap we had previously. So I'm going to split it at center there. I'm going to split this one, and I'm going to go back to center there. And I'm going to split this one at center, wherever that is. Center. Having a job finding my center. I'll go back to this one. Pretend that never happened. Here we go, center. There it is. And this one, center. There, look, there it is. Alright, better luck second time. So what I've done now, these are individual parts. It's a good way of putting your bends in. If I even had a bend on the end of here, I would probably either draw a polyline using the end points, the standard polyline, straight line, radius, straight line, radius. And I would draw the end of this, and or the other way I could do it, of course, I could put a bit of tube between here, I could radius it and join it and split it and split it, so I could have the D ends on the railings. If we leave it up to advanced still, we end up with a straight, a bend, a straight, a bend, a straight, a bend, and your material list shows all those components. All I want is a piece of tube, overall length with a bend in, and that's it. Alright, so there we are. Works fine. Not too much work. Once you get into the swing of it, yeah, you can do miles of this in a day. It's not tricky. I try to use flat here. You can't put a railing on a plate, unfortunately, but you can put it on a flat. That's it. Nothing more to show you there. So until next time, hope that's helped everybody. Hope you can see it's not the end of the world if you need to do this kind of railings. Takes a little bit of setting up, but I try and put the railings on using the advanced macro. The reason I do that is because it sets out the spacing for the rails. It does the mathematics for me, and all I need to do then is just delete the bits I don't want, put in the bits I do want, and hey presto, ball post railings. I noticed that Autodesk is starting to play with this a bit. They call it mono wheels, but it pretty much does the same thing. I haven't had much success with it as it is. I think it's a work in progress, so hopefully they will improve on that, and over later versions that'll get better, and it's going to save us a lot of work once they do that. But for now, here it is. Okay guys, that's it. I'm off to have a loaf about, and until next time, have fun with Advanced Steel, and I'll speak to you again soon. Thanks very much for listening.